This video is covering section 8.2 and 8.3, multiplying polynomials, but extended notes. So I already talked about how to multiply polynomials. Now we're going to look at some applications with that. So our first example is to solve. And as you can see, on both sides of my equal sign, I need to simplify those things. So we're going to simplify both sides, and then we're going to solve. So these first set of parentheses, I'm going to distribute. So I get a squared minus 3a. Second set of parentheses, distribute again, and you get plus 2a minus 6. Then, on the other side of the equal sign, we distribute two more times, a squared plus 7a. And then remember here, where a lot of people tend to mess up is you're distributing a negative 3, so that's going to change the signs. So negative 3 times a is negative 3a, and then negative 3 times 7 is negative 21. Now, we still don't want to move things around on either side of the equation, so I'm going to simplify my like terms. So I'm going to see on the left side, I have negative 3a plus 2a. So again, I'm only looking at the left side of this equation. I don't want to go over to the right side yet. So simplifying that, we have a squared. Then negative 3 plus 2a is negative 1a, which we write as just negative a, minus 6. Then on the right side, we see we also have like terms, 7a minus 3a. So I'm going to solve that, or simplify that. So that's going to be plus 4a, and then minus 21. Okay, so now we're going to solve. So what we want to do is we want to get all of our a's over on one side to solve for a. And if you'll notice, we have on the left side a positive a squared, and on the right side a positive a squared. So what's going to happen is if I were to remove that a squared, those are actually going to completely cancel out, which is really nice. All right, so the a squareds cancel out, so now I want to get a by itself, and this is just a normal problem like we've solved before. So we have a on either side, so I need to move one of those. I like to keep things positive, so I'm actually going to add this a over. And so when I do that, I want to also move this 21 over, so I'm going to add 21 to get rid of the number on the right side. So then I'm going to simplify. So negative 6 plus 21 is 21 minus 6, so that's 15. And then 4a plus 1a is 5a. And then when you divide by 5, you get a is equal to 3. Okay, so the same thing we have been doing, is just we had to multiply our polynomials first. Okay? All right, so for example 2, this is definitely a very important application problem. So this kind of takes things a little bit farther. So what we have here is we have two rectangles. Or you can kind of think of it as like a piece of paper, and then I cut out a rectangle inside that piece of paper. So if you think of the blue region as that paper, and then the white region inside as like that hole in that paper that I cut out, what I want to find is the area of that leftover region, so that blue region. So in order to do that, we're going to find the area of the big triangle, so like what the original piece of paper would have been. And then we're going to find the area of the small, so that would be the piece of paper that I cut out, and then you just simply subtract those two. So we've got a lot going on. So I like to separate, and I like to organize. So that's why I wrote big and small. So I'm going to find the area of just the big rectangle. And remember, the area of a rectangle is length times width. So if you think of this as the length, and this is the width, then we're just going to multiply those two things together. Now you see that the width is 3x, which is a monomial. When I have a monomial and then over here the length is a binomial, I like to put the monomial first. So I'm going to put 3x and then times 8x plus 2. It really doesn't matter. I could put the monomial second, but this is, I think, what you normally will see. So now I'm going to multiply that monomial, so I'm going to distribute inside my parentheses, and I will get 24x squared plus 6x. So that's the area of the big piece of paper before I cut out the other rectangle. So then the small, we're going to do the same thing. So the small, we have the same length here, not the same length, but that same side is the length, and then the width here is x. So now, again, I'm going to do the monomial first, which is x times 3x minus 4. Distribute, and we get 3x squared minus 4x. Now, all we have to do to find the area of that shaded region is to subtract big minus small area. Now, here's where you have to be careful. Because of that subtraction sign right there, you're going to have to put our polynomials in parentheses. So that is, the big one is 24x squared plus 6x. That's in its own parentheses. Then minus the small, which is 3x squared minus 4x. So the reason we have to do that is, remember when we were subtracting polynomials, that negative right there has to distribute inside to both of these terms. That's a big thing that people will miss. And some of you are trying to do this all in your head without writing it out, and you're making mistakes. So I would recommend you write this out. Doesn't take that much time, so that you don't make the mistakes. That negative times a negative becomes plus 4x. And that plus 4x right there is what most people are going to forget. All right, so now I'm going to combine like terms. So I have 24x squared minus 3x squared. So that is 21x squared. And then I have 6x plus 4x, which is 10x. So that expression right here represents the area of that blue region that's left. Okay, now for example 3. When we were multiplying polynomials in the last video, I was only multiplying 2 polynomials. Now I want you to see for part A, we can actually multiply 3 polynomials together. But you have to do it in 2 separate steps. So you can't go ahead and multiply all 3 together the first time. So what I'm going to do is think of PEMDAS. We do multiplication. So we have the n plus 2 times n minus 2, and then we have times n minus 3. But by PEMDAS, we multiply from left to right. So what I'm going to do is I'm going to think of those first 2 as if those were in like parentheses. Like I have to do those first. So what I'm going to do is I'm going to multiply n plus 2 times n minus 2 first and simplify that, and then I'll multiply by n minus 3. Okay, so don't try to do it all at one time because it's not going to work. So we're going to do the double distribute method. That's my favorite method. If you want to do the box method, feel free to do that as well, but I'm going to do double distribute. So that is just a reminder how to multiply binomials. The first term skips over and goes to m minus 2 in the second parentheses. So that will be m squared minus 2m. Then the next term, the plus 2, also gets distributed, and that would be plus 2m minus 4. Now, I'm going to put that whole thing, because remember I put those brackets around it, that whole thing is like a new polynomial. So I'm going to keep that all in together. And then that m minus 3, I have not touched that yet, but it's still there waiting for me. Before I multiply by m minus 3, I'm going to simplify what I have in blue by combining like terms. So here I have a negative 2m plus 2m, and those actually cancel each other out, leaving me with m squared minus 4. Okay, so that simplified quite nicely for us. So now our next step is we're going to have to multiply that m squared minus 4 times n minus 3. And we're going to do the same type of steps that we did before. So we're going to distribute m squared into m minus 3. And that would be m squared times m is m cubed. M squared times negative 3 is negative 3m squared. Then we have negative 4. And make sure you include that negative with that 4. Times m times negative 3. So when I do that, that will be negative 4m. And then the negative times the negative becomes positive 12. Look for like terms. There are none. And also I want you to notice that it's written in descending order of exponents. So this actually is my final answer. Okay, so another example with a lot of operations going on. So this is like multiple operations. So that means more than just one multiplication. We're multiplying and adding, subtracting, all that kind of combined. So for part B, you see you have two binomials that are being squared. So just to review, make sure you don't just square both of those things. We have like the c and the 4. You don't square c and square 4, and that's your answer. That is incorrect. So what you have to do is multiply c plus 4 times another c plus 4. So that's how you would do this problem. Now, I'm going to look at this as like two separate polynomials that are then going to be subtracted. So then I'm going to subtract, and in a different color, I'm going to do c minus 3 is squared, so that's times another c minus 3. Okay, so I'm going to do just the blue by itself, just the red by itself, because following PEMDAS, we're going to do the multiplication. So this is multiplied, and the blue is multiplied. So I want to do those first, and then we'll get to the subtraction last. All right, so I'm going to quickly, what I want you to do is pause the video. I want you to do the blue by yourself and the red by yourself, and then we'll come back together and subtract. Okay, so I multiplied and simplified the blue side and multiplied and simplified the red side. So you see that I combine like terms there. Now notice that I kept parentheses around those entire polynomials because again, this negative right here, what we're going to have to do with that is distribute that inside the red. So if you drop off those parentheses, you're going to get the wrong answer. So now go ahead and rewrite this by distributing through the negative. You should get something that looks like this. So I changed the sign of everything that was inside the red. Now we're going to combine like terms. So in this problem, we get as our final answer 14c plus 7. So again, as we're adding all these crazy things, just make sure to keep PEMDAS in mind. So you do the multiplication pieces first, and then you add or subtract. Okay, for our final example, we're going to look at a cube, which remember a cube is when all sides are the same. So they've labeled the side length x minus 3, so that's the length, also the width, and also the height are all x minus 3. And they wanted to find the volume. So the volume of a prism is length times width times height, and more importantly for a cube, all the lengths are the same, so when I multiply those three together, you have x minus 3 cubed. All right, so we want to simplify that down. Now, just like what we had before, if we had x minus 3 squared, you cannot just cube the x and cube the 3. For instance, the answer is not x cubed minus 27. Okay, do not do that. So what we have to do is we have to write out x minus 3 times. And I know that's tedious, but that's how you have to do this problem. So just like way up here in example 3, part A, we had 3 different binomials multiplied. Same thing with example 4. So I'm going to look at and think of the first two as grouped together and simplify that first. So I have x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x, again, negative 3x. And negative 3 times negative 3 is positive 9. Okay, and then if I simplify that by combining my like terms, you'll get x squared minus 6x plus 9. So that simplifies there, and then I still have this x minus 3 that I can now multiply by. Okay, so now I have a trinomial times a binomial. Now, I see that my binomial is written second, and my trinomial is first. That's okay. If you like the smaller one to be written first, you can, by all means, put it first. But I'm going to show you that you can do it this way as well. So I'm going to start with my first term, x squared, and skip over everything and go to what I've written in black. So x squared times x is x cubed. Then go to negative 3. So that's x squared times negative 3, so negative 3x squared. Then you just move along your trinomial. So then next you have negative 6x, and so that distributes. So negative 6x times x is negative 6x squared. Negative 6x times negative 3 is positive 18x. And then finally, you would have the positive 9. which also is going to distribute. So 9 times x is 9x, 9 times negative 3 is negative 27. Okay, so now we just look for our like terms. X cubed is the only x cubed. Negative 3x squared and negative 6x squared make negative 9x squared. And then 18x plus 9x makes plus 27x, and then minus 27. So this is my final answer, and that represents the volume of that cube. And you can see that's very much far away from if I had just simply cubed the x and then cubed the 3. It's not x cubed minus 27. I've got a lot of extra stuff going on here. Okay?